Last year, using the exoplanets discovered by the Kepler Space Telescope as a guide, astronomers took a statistical stab at estimating the number of exoplanets that exist in our galaxy. They came up with at least 50 billion alien worlds. Today, astronomers from the Space Telescope Science Institute (STSCI) in Baltimore, MD, and the Planet Probing Lancing Anomalies Network collaboration have taken their own stab at the galactic exoplanetary estimate, and think there are at least 100 billion worlds knocking around the Milky Way. Why has the estimate doubled? The key difference here are the methods used to detect alien worlds orbiting distant stars. The Kepler Space Telescope watches the same patch of sky containing around 100,000 stars, and waits for slight dips in starlight brightness. This dip occurs when an exoplanet passes in front of its parent star, thereby blocking a tiny fraction of light from view. This slight dimming effect is known as a transit, and when 4 transits are detected by Kepler, the announcement of a confirmed exoplanet can be made. The transit method has proven itself to be an excellent way of spotting exoplanets, but the method favors the detection of large exoplanets and exoplanets that orbit close to their stars. Pretty obvious really, the closer or the larger the exoplanet, the more starlight can be blocked and the bigger the dip. However, to arrive at their galactic exoplanetary estimate, the Planet team employed a rather different and more random exoplanet detection method known as microlensing. Microlensing depends on a lot of patience and a lot of luck, but given enough time and enough stars, exoplanets can be discovered this way. From our perspective, as stars drift around the sky, occasionally one star will drift in front of another. The starlight from the more distant star may become bent around the foreground star by its gravity, causing the light from the background star to brighten for a short period of time. The foreground star has basically acted as a magnifying lens, focusing the light from the background star for astronomers on Earth to observe. The more massive the star, the longer the brightening event. This is where the clever bit comes in. Should the foreground star have an exoplanet or a system of exoplanets in orbit, its additional gravity will create another brightening event, thereby allowing astronomers on Earth to measure the exoplanet's mass and orbit. Typically, the microlens brightening caused by the star will last about a month, and the brightening caused by the presence of an exoplanet will only last a few hours. Microlensing events are random occurrences, and don't depend on star selection. Also, the method can detect exoplanets as small as Mercury and exoplanets orbiting as far from their host star as Saturn orbits the Sun. Kepler's transit detection method favors the detection of worlds orbiting close to their stars, whereas microlensing has no such restriction. So, when the Planet collaboration detected 40 microlensing events, and noted that 3 contained exoplanets, they could do a statistical analysis to estimate the number of stars that have exoplanets in our galaxy. From this analysis, the Planet team made a rough estimate of 100 billion exoplanets living in our galaxy. Additionally, they found that 1 in 6 stars host a Jupiter-mass exoplanet, half the stars in the Milky Way have Neptune-mass exoplanets, and 2/3 of the stars have Earth-mass worlds. Interestingly, this result points to at least 1,500 exoplanets within 50 light-years from the Solar System. As already uncovered by the Kepler science team, smaller worlds appear to dominate our galaxy. The Planet collaboration supports this idea. This means, statistically, every star in the galaxy is likely to have at least 1 planet, and probably more, said Kailash Sahu, STSCI astronomer and co-founder of Planet. Results from the 3 main techniques of planet detection, radial velocity, transit and microlensing techniques, are rapidly converging to a common result. Not only are planets common in the galaxy, but there are more small planets than large ones, said Stephen Kane, of NASA's Exoplanet Science Institute at the California Institute of Technology, Pasadena, California. This is encouraging news for investigations into habitable planets. Of course, this statistical analysis is just a projection, and based on the very thin knowledge we have about the real distribution of alien worlds throughout the Milky Way. The number could be wildly different. But the more we look, the more exoplanets we discover, and the more we realize that our solar system is not unique. But is Earth unique? Unfortunately, we cannot fully understand the atmospheres of these distant worlds, and so cannot reveal if any are true Earth analogues. But with enough time, patience and scientific ingenuity, the answer may not be too far away.